Good morning, everyone. It's June 1st. Make sure you answered your attendance question and checked the answer key to Thursday's assignment if you submitted it. I also left comments on every single person's assignment. If you did not get 100%, you can redo the problems that you did incorrectly for full credit back on separate files. Make sure you have these notes printed out that were attached to the post. If you don't have a printer, if you don't have ink, just work on line paper in your math notebook. You have to write down every single thing to get credit for this assignment. You are posting both sides to the assignment posting. We're not done with logarithms. They do have properties, just like exponent properties. So we're just going to go over the three properties and do two different sets of examples. You're going to have two examples to do on your own, and then you'll take pictures and upload. The definition of a log, just to remind you, is it can be unraveled with an exponential. Logs and exponentials are opposites of each other, just like multiplication and division are opposite operations of each other. They undo each other. So if you have log base m of a equals n, you can undo it with an exponential m to the n equals a, which I called popcorning in my original video. Logs have three properties. This one you discovered on your own on Thursday. So from the first example, so if you have log base m of a to the n, let's say the thing inside the log is being put to a power, you can bring that power to the front and just multiply it with the log. This is a similar property to the power property from exponents, because if you put a power to a power, you would multiply them. So logarithms say if you have a power, just multiply it in the front, bring it to the front. Two more properties are product and quotient. So if you have two things that are being multiplied within the log, you just expand them with two logs with an addition sign in between and make sure they do end up having that same base when you do expand them into two different logs. This is similar to exponents because if you had to multiply with the same base, you would add the exponents. And similarly, if you had to divide with the same base, you would subtract the exponents. So the logarithm quotient property says if you're dividing within the log, you separate them with addition and make sure they do end up having that same base. So anytime you have one log and you're told to expand it, you should have more than one log. And anytime you have more than one log and you're told to condense it, you should end up with one log completely. So we're going to do all these examples together. Again, you're going to have two to do on your own. So example A says, or the directions, expand each logarithm into a sum or difference. So we see one logarithm each, we should be expanding them into more than one. So in letter A, the base was not written, but remember I said this in a previous video, if the base is not there, it's understood to be 10. You don't have to write it if you don't want to. I like to, so I'm just going to put log base 10 so that you recognize it. Next step is to recognize what operations are going on because that'll affect which property we choose. What operation is between the 10 and the x? It's multiplication. 10 times x. How do you separate multiplication with logs? That's your product property. Separate them with addition. So I'm just going to expand with an addition sign. 2 logs with a base of 10. Again, you do not have to write that base of 10 if you don't want to. And I have completely expanded log base 10 of 10 times x with an addition sign. In letter B, I have something similar. I see the multiplication sign, so I'm going to similarly expand that with addition, but I do have one extra step. So this has a base of 4. Make sure when you expand, they both have that base of 4. Four times x squared, so the 4 and the x squared get expanded into two separate logs. I do have one more property to use though because I see an exponent. So anytime you see an exponent inside the log, you can bring it to the front and multiply it with the log, and that is my last step. 2 times, and it's just a regular 2, it's not a squared. 2 times log base 4 of x. And that's 2 steps to completely expand letter B. Okay, let's try letter C. We're getting more difficult as we go along. So in letter C, I see multiplication in the numerator, and I see division, dividing by z. Again, there's no base. It's understood to be 10. So I'm not going to write it this time just to show you this type of example. What I'm going to do first is I see something being divided by something. So I am going to automatically use my quotient property, which says I separate with subtraction. So log of xy minus log of z. I'm not done yet though because I still see multiplication from the numerator. How do you separate multiplication, product property, with addition? So I'm just going to separate this into log x plus log y, and I'm going to keep my minus log z on the end. So this had two operations. You should be expanding it twice. Multiplication and then the division. I did division and then multiplication. Sorry, wrong order. Okay, and they all have the same base of 10. It's not written there. Okay, letter D. This is a bit tricky because I don't really see multiplication, right? I don't see division. I don't see an exponent, but you have to remember square root is the same as the 1/2 power. So technically there is an exponent here. I'm going to rewrite this as x minus 2 to the 1/2. Don't be confused and see subtraction and separate it with division, right? In the condensed version, you can only see multiplication, division, and a power, and then you separate with addition, subtraction, or the multiplication in the front, okay? So right here, I can't separate with a division sign. It doesn't work that way. If I see division, I can separate with the subtraction sign. So here, all I can use is my power property. I bring my power to the front, and I'm all set. So I'm bring 1/2 to the front, log base 3 of x minus 2, and I'm done. I can't do anything else because I don't see multiplication or division within the log. If you want to write this whole thing divided by 2, that means the same thing as multiplying by 1/2. You guys are going to try example E on your own. So that's a log base b. And then here you have x to the 4th over z squared. So see what properties you have to use. You're going to have to use more than one and expand what you can. The other type of example is when you condense. So you're given more than one log and you have to condense to 1. Remember, you should only end up with 1 in the end. And you're using the same 3 properties. So here I'm going to work backwards and I see subtraction. So anytime I see subtraction, I condense with division with that base. So again, this didn't have a written base. It's understood to be 10. 7 over x. You can write 10 right there if you want to. It's not necessary. Similarly, I see the subtraction again, but I also see the coefficients. So what happens, where do I move the coefficients back if I have them? I move them back as exponents. I'm going to use my power property first to move these exponents back in their place, and then I'm going to use division to condense the subtraction sign. So log base 5 of 7 to the 1/2. You can also write the square root of 7 because the 1/2 power is the same as the square root. Log base 5 of x squared. So there I use my power property. And now I'm going to condense with my quotient property because anytime I see 2 logs being subtracted with the same base, remember it's important they have the same base because that means they're like terms. Okay, you guys know that as like terms, same base. I can condense with division now. Log base 5 of, I'm just going to write that as root 7 over x squared. If you would like, you can put that parentheses. So I moved with the power property, and then I condense with division using the quotient property. Okay, 2 more, and then you're going to try J on your own. So here again, I see these coefficients. They should be moved back using the power property, putting them back as exponents. You shouldn't leave stuff like 8 squared, that's 64. Okay, so when I rewrite that, I'm just going to do 64. If I have 2 logs being separated with addition and they do have the same base of 10, it's not written, they can be condensed with multiplication. So log of 64x to the 5th. Okay, we're going to try one more. It's a bit more difficult than the others. So I see a 1 and I see a 3 times log base 4 of x. So I'm just going to do what I know. Like I see a coefficient, I'm going to move it back as an exponent. Now what do I do about the 1? Remember, we can't condense them, and you do have to condense to a single logarithm. So I have a logarithm, but I have adding 1. It needs to be a single logarithm. How do I convert 1 to a log? with the same base, because remember, they have to be like terms. So I know I'm going to have like terms. It has to be log base 4. But log base 4 of what is equal to 1? So 4 to what power? Or sorry, log base 4 of what is equal to 1? I'm just doing work for this part. 4 to what power? 4 to the first power is this. 4 to the first power is this. When I unravel it, it's 4. So anytime you want to convert 1 back to a log when you're condensing, you just have the same base, like you just put the base here as well. Log base 4 of 4 equals 1. If you do put this in a calculator, it does equal 1 because 4 to the first equals 4. So I'm just going to convert 1 to log base 4 of 4, because in this case, log base 4 of 4 is the same as 1. And I see an addition sign now, so I'm going to use my product property to condense with multiplication. And that's pretty much it for these. There's only 3 properties. If you have any questions, please comment in the YouTube video down below or in Google Classroom. You are doing E and J on your own. And remember, you have to write down everything and upload pictures of both sides of these notes. So again, let me know if you have any questions, and enjoy the rest of your Monday. Bye.